I would like to present a general introduction in the chemistry, pharmacology, and initial clinical effects of cannabinoids. When we started work on cannabis and the cannabinoids about 50 years ago, I was surprised to find out that it was a topic that very few investigators were involved. This was surprising because the chemistry of opiates and cocaine had been investigated for many years since the middle of the 19th century. One of the reasons for the lack of interest at that time, and I'm speaking of the early 60s, were illegal. Cannabis was obviously considered an illegal drug, and in most academic institutions it is very difficult to work with illegal substances because students come in and out, and obviously a professor cannot take care of every second of what's happening. Surprisingly, we didn't have these problems. I was able to obtain cannabis from the police, and we went ahead looking for the components that were active in the stuff and go ahead with pharmacology. Now, since then, interest has bloomed, and there are thousands of papers published on cannabinoids of various types. And the reason for this is it has been found that cannabis, in addition to its illegal use, has considerable medical properties, and the cannabinoids, the different cannabinoids, have different activities, and therefore they can open the door for new types of drugs. Indeed, Nature, one of the major scientific journals, had 4 reviews recently, and this is the review we wrote, and they had it on the front page. As you can see, a brain with cannabis growing out of the brain. As I said, the reason for this interest in scientific circles is that it has been found, and I quote, "Modulating endocannabinoid activity may have therapeutic potential in almost all diseases affecting humans." And I'm citing here 2 scientists from NIH in Washington, and they give detailed references to all the diseases they have been looking at. But cannabis was actually used both as a recreational drug and as a therapeutic drug thousands of years ago. And here is something that we found of the use by Assyrians. They called ganzigunu, the drug that takes away the mind, which is essentially the recreational part of cannabis. But they used also the name azulu, which was apparently for a drug used in neurological diseases. As a matter of fact, they also used cannabis as part of their religious rites. But the use of cannabis as a medicinal agent has followed many years. As a matter of fact, I just pointed out the Assyrians 3,000 years ago, but here I have a quotation from Dr. Russell Reynolds, who was the physician of Queen Victoria, and he used to import cannabis from India because Queen Victoria had serious migraines, and cannabis, Indian cannabis, was the only one that helped her. Usually, when we speak of cannabis today, people think of the plant alone and the components of the plant. But obviously, this is only part of the picture. Today, we know much more, and I can look at cannabis research as passing through 3 phases of research. One of the original one was the phytochemical, the compounds that are found in the plant and they are obviously used both as recreational drugs and as therapeutic ones. But over the last 25 years, a lot of work has been done on the compounds that mammalians, we produce in our brain, our body, and actually THC, which is found in the plant, mimics the activity of the endogenous cannabinoids. So I consider this as the second part of cannabinoid research. And over the last 10 years, it has been found by quite a few groups, including ours, that these endogenous cannabinoids are not the only ones of their type. There are many additional compounds found in the body, about 100 additional compounds, and many of these have a variety of therapeutic effects or biological effects. So I will try to discuss all three types, domains, if you wish, of cannabinoids and cannabinoid research. Let's start with the phytotherapy. The phytochemicals, and here is a list of some of them. A few of them were already known in the 1930s, but their structure was not well defined. We re-isolated, starting the early 1960s, some of these known compounds and a lot of additional new ones. And we found that these compounds have a general structure of an aromatic part, and this is the right-hand side of the molecule, which is more or less the same for all cannabinoids. But then the left-hand side is derived from terpenoids, and they differ, and they make possible the synthesis in the plant of a large number of cannabinoids. And here are a few examples: cannabigerol, cannabidiol, THC, cannabichromin, cannabicyclone, and many of these we identified at that time. Most of the work, however, over the last decades has been done on two compounds, cannabidiol and THC. Surprisingly, although they are chemically closely related, they differ completely in their biological activity. Cannabidiol is not psychotropic, does not cause the well-known cannabis effects, while THC is the major, probably the only compound which causes the psychoactivity of cannabis. But surprisingly, these compounds are not the compounds, the actual compounds that the plant synthesizes. The plant synthesizes their precursors, the acids. These acids are formed in the plant. They are, and here are a few examples, cannabidiolic acid, THC acid, and so on. But these compounds are not stable, and they convert easily into the neutral compounds, which are much better known. But over the last few years, there has been interest in these major components of cannabis. The cannabidiolic acid, for example, has been found to affect depression. It also has other effects. And before I go into detail, I want to mention something which has been used over the last few years, mentioned in many papers. This is the entourage effect, which we described and coined the term about 25 years ago. We found that many of the activities of cannabis are not due to a single compound, but the one compound which is there, which acts, its activity may be modified by additional compounds that do not have that type of effect. And so here we have not synergy, namely two active compounds work together. Here we have an active compound whose activity is changed, is modified, if you wish, by compounds that do not have that type of activity. It is called the entourage effect. Now, the entourage effect has practical implications. People prefer to use extracts of cannabis, of the cannabis plant, rather than the pure cannabidiol, the pure THC. And the reason is that the additional compounds found in cannabis affect the activity of THC or change to a large extent its activity, and people using cannabis prefer to take the extracts rather than the pure compounds. Now, what are the compounds of THC, the major psychoactive compound? I will not go into great detail, but it has been shown that it definitely lowers pain, lowers nausea and vomiting, which during cancer chemotherapy major side effects. It affects sleep. Many people have found that they sleep much better when they have taken THC or cannabis. Anxiety is affected by THC. At lower doses, THC can modify, can suppress anxiety. And one of the reasons so many people use cannabis is because it actually lowers anxiety. However, at higher doses, it can cause anxiety. And indeed, many people that use cannabis for the first time, youngsters, take too much cannabis and end up with a psychotic attack in the hospital after using it for the first time. So here we have two types of activity, both lowering anxiety and enhancing anxiety depending on the activity. THC has also been found to enhance appetite, particularly for sugar type foods, and it has been shown that it affects post-trauma. Not all of the post-trauma effects can be affected by THC, but by helping with sleep, for example, THC is very helpful because patients with post-trauma are afraid to go to sleep. They are afraid that in the middle of the night they will wake up with whatever caused the trauma. Here, cannabis or THC helps to a large extent. I mentioned the post-trauma, and indeed a colleague of ours, Dr. Reutemann, the Department of Psychiatry, found that THC or cannabis can be very, very useful. But surprisingly, today we know the reasons, but surprisingly, over the last few years, most interest has been at CBD, at cannabidiol, the compound that does not cause psychoactivity, but has a huge number of positive therapeutic effects. For example, 1980, almost 40 years ago, we found that CBD, cannabidiol, CBD, affects epilepsy. This was done in collaboration with colleagues in South America, and after working with mice, and other people had also done work on mice, we went and did a clinical trial with patients that nothing else was helping them, and we found that high doses of cannabidiol definitely helps with the effects of epilepsy. Many of these patients, and as I said before, nothing was helping them anymore, did not have attacks or had very few attacks during the 2 months they used high doses of cannabidiol. Just as an aside, I would like to mention that at that time, obviously, cannabidiol was not commercially available, and we had to isolate nearly half a kilogram of cannabidiol because the patients got 200 or 300 milligrams of cannabidiol each day for a period of several months. So we were sorry to see at that time that although we had shown that cannabidiol helps with epilepsy, it was not being used. There were children that have epilepsy, nothing was helping them, and yet cannabidiol was not used. Well, over the last 10 years, parents had maybe seen the paper or heard from other people that CBD helps with epilepsy, started using, in the US in particular, started using plant extracts with high doses of cannabidiol and found that it's useful in many cases. And there was pressure in the US, and the US Food and Drug Administration allowed a clinical trial with cannabidiol, which was completed a few months ago. It was very positive, as we had seen almost 40 years ago. And today, cannabidiol is an approved drug for certain types of epilepsy in children. Well, why did we have to wait 30, 40 years? We could have helped thousands of children, thousands of patients. Well, it seems that anything that has to do with cannabis moves slowly. At the moment, there is a clinical trial that's going ahead. It is on the basis of work that was done by Dr. Yeshurun in one of the hospitals in Israel, who found that cannabidiol can lower the effects of graft versus host disease. This is a disease that is a man-made, if you wish. In many cases of cancer, the bone marrow has to be transplanted. A person with certain types of cancer is being treated by a bone marrow transplant. Now, it works pretty well in many cases of cancer, but the transplant, being an outside tissue, is being attacked by the body, and the transplant itself attacks the body, and the patient may be sick, sometimes very sick. And this is called graft versus host disease. And Dr. Yeshurun found that indeed cannabidiol is very helpful. This is not surprising because graft versus host disease is a kind of a autoimmune reaction. Autoimmune reactions are reactions in which the body attacks itself for reasons that we're not so sure, and there are about 100 diseases of this type, 10 of which are very central diseases, for example, diabetes type 1, and the body attacks in diabetes the cells that produce insulin. In this case, the transplant, which is present now in the body, is being attacked by the body, and it is kind of an autoimmune reaction, or the transplant itself attacks the body. So Dr. Yeshurun found that it is very helpful, and in many, many cases it lowers the symptoms of the disease to a large extent. And so now CBD is in phase 2 clinical trials, and I hope that the phase 2 and phase 3 clinical trials will be successful, and the cannabidiol will become a drug generally used for graft versus host disease. Another disease in which cannabidiol has been shown to be quite active is schizophrenia. Here, however, the doses needed are extremely high. A group in Germany, headed by Dr. Leveke, found that cannabidiol at high doses, about 800 milligrams per day, can lower or eliminate even attacks of schizophrenia. This was done on about 40 patients, and they were given cannabidiol at these very high doses, and this was published about 5 or 6 years ago, and Leveke showed that indeed cannabidiol is very helpful. Now, cannabidiol does not cause any side effects, so in this respect it's a drug that can be used without the danger of side effects, which sometimes are quite strong with other drugs. In schizophrenia, they are very good drugs at the moment, but most of them cause side effects, and patients sometimes say, I prefer not to take the drugs because nothing else is helping me. Well, cannabidiol was shown by Leveke and also by others that it is a very helpful drug. And yet, it is still not being used in schizophrenia. Why? Difficult to say. I hope that it will be. I mentioned diabetes type 1, which is an autoimmune disease, namely the body attacks itself. It was found, we found, in collaboration with our colleagues here at Hadassah Hospital, we found that cannabidiol can save the cells that produce insulin. And by saving these cells from deteriorating, they continue to produce insulin, and in mice at least, the disease is not present in many cases, or it's in a mild form. And if one looks at the cells that produce the insulin, we found that those animals that were treated with cannabidiol, these cells that produce insulin, about 77% were still intact. Those that did not get cannabidiol had only 5% of intact cells, and the mice had a severe case of diabetes, and they died within a few months. Again, this was done in mice. It should have been done in humans by now because the mechanisms are the same. What we saw in animals, attack on the cells, we see in patients, usually in children. The body attacks its own cells. So the mechanism is the same. Chances are that cannabidiol will be an excellent drug in this case. It has never been tried in humans. Why? I have no idea. Now, I described the activity of the major compounds found in the plant, and I will not go into details on the activities of other compounds there, cannabigerol, cannabichromine. There are quite a few others, but there has not been so much work on these compounds, and I will leave the plant at the moment. As I described in a few words, there has been a lot of work on the plants, but one thing was not known until the mid-80s, and this is the mechanism. In the mid-80s, a group in the US found that THC binds to a receptor. It is now known as the cannabinoid receptor 1. And this receptor is found in those areas of the brain which are very relevant for cannabinoid activity. Areas that have to do with movement control, they're called basal ganglia, the coordination of body movement in the hippocampus, with cognitive functions, and so on. So it seemed to be relevant, and today there has been a lot of work on the CB1 receptor, and indeed is a specific receptor for cannabinoids, and it is major receptor, probably the receptor which is found in the highest concentrations in the brain compared to many other receptors. Now, receptors are not made in our brain, in our body, because there is a plant out there. Receptors are present in order to be activated by compounds, constituents that we make, that the animal body makes. And by chance, a plant, in this case the cannabis plant, makes compounds that activate the same receptors. So we went ahead looking for the compound that we make, that the animal body makes, that activates these receptors. And this is done by taking the THC and putting a radioactive compound, and then the THC goes and binds to the receptor, and we can isolate in this way the receptor. And here is THC, or a derivative of THC, which we can put on a radioactive substance, and indeed the compound, the new radioactive substance, was we found to be binding to a receptor. And so we started looking for the compounds in the body that bind to these receptors. And I will not go into details, but after a few years of work, we found two compounds that our body, the animal body, makes, and these compounds bind and activate the receptor. We call one of them anandamide, and the second one is known as 2-AG. Now, these compounds have turned out to be of extreme importance. They are major new neurotransmitters. They are involved in a huge number of body reactions. They are involved in a huge number of disease states. And these two compounds have been the object of research in thousands and thousands of papers. These are, as you can see, different structurally from THC. You have the structure of THC on top, and you can see that the compounds that our body makes are completely different, and yet they act exactly in the same way. With one difference, the compounds that we make are formed in the body, they act and are immediately broken down. So they do not cause the effects of cannabis that we know, the marijuana type effects. THC stays in the body for a longer time, and therefore it can cause the effects, the well-known marijuana effects. I will not go into the biochemistry, of course, but we'll say I have just one slide. Anandamide and 2-AG, the compounds that we make, are not formed in large extent in the body. It is formed only when needed. And if you have a nerve, and the nerve doesn't go, it's not like going from the one place to another like a string. There are always breaks. They're called the synapses. And this is done by the body in order to regulate nervous activity. So anandamide and 2-AG are formed in what is called the postsynapse. They are formed there when needed. For example, if there is pain, they move to the presynapse, activate the receptor which is there, and start acting by their own activity, and also by affecting, regulating the release of other neurotransmitters. So they have two roles, both as regulators and as activities, and as the compound that act on their own. Now, the receptor and the compounds we discovered, the endogenous cannabinoids, the endocannabinoids, and all the enzymes that form them or break them down, they form a new physiological system which is called the endocannabinoid system, and it is a physiological system of major importance. Now, where is this endocannabinoid system involved? Well, as I said before, there are almost all biological reactions that are taking place in our body are somehow related to the or close to the endocannabinoid system. And it has been shown that the endocannabinoid system is involved in anxiety and appetite, blood pressure, bone formation, digestive system, so on and so on. If I had to make this slide again, I would have another 10 or 15 types of reactions taking place. And this is why there is so much interest today in the medical therapeutic side, because by modifying the endocannabinoid system, one can produce possibly new drugs. And indeed, quite a lot of companies today are working on the cannabinoid system, looking for new drugs based on the endocannabinoids. And I'll just give one example, and this has to do with neuroprotection. When the brain is hurt, maybe damaged, it starts to produce 2-AG. So we asked ourselves, why does the brain do that? Is it because it has been damaged and it doesn't know what it's doing, or is that some kind of reaction? And here you can see the red thing, which shows that compared to the controls, the amount of 2-AG goes up tremendously. Now, why? So we synthesized a lot of 2-AG, and Professor Mechoulam, who is a specialist in brain trauma, looked at animals that were given synthetic 2-AG after trauma, and she found indeed that those animals that received 2-AG, in addition to the large amount of 2-AG that the brain makes, have much lower damage. In the control, there is a certain amount of damage. You can see the white here of the damaged brain. If the animal gets 2-AG, the damage goes down in mice about 50%. I hope that this will be further developed as a neuroprotective agent in humans. Recently, it was found that 2-AG actually works on depression. The 2-AG in people that have depression is lowered. Maybe 2-AG or a related compound can be used in depression. And this is a field that is being looked into today. And as I said, there are receptors, two receptors. One is the CB1, the other is the CB2. The CB1 causes, when it is affected, when it is stimulated, it causes the well-known marijuana effects. But the second receptor, the second cannabinoid receptor, doesn't do that. It is a protective receptor. It has been found to be involved to help with problems of the heart, with atherosclerosis, with stroke, and many other diseases. And again, some major companies today are developing specific compounds which act only in the CB2 receptor and do not cause any of the psychoactivity of marijuana, because they work only on the protective mechanism. And hopefully within the next few years we shall see compounds on the market as drugs against many of these diseases. And here are molecules that work only on the CB2. Now, I would like to end up with compounds that our body makes and are very close to the neurotransmitters I mentioned, very close to anandamide. anandamide is made of a fatty acid bound to an amino acid. Well, in the body we have many fatty acids, many amino acids, so the body uses the same mechanism, makes a lot of compounds, and some of these compounds of great interest. We found, for example, that on brain injury, we have two ways that the brain injury causes damage. One is through all kinds of compounds called glutamate and cytokines and so on, and they cause neuronal cell death. But in addition, the brain injury causes also vasoconstriction. The blood vessels are constricted, and this is not a positive thing. The blood vessels should not constrict, so the body tries to prevent or lower the vasoconstriction. How does it do it? Well, we worked and found that the body can regulate to a certain extent the vasoconstriction. It causes vasodilation, and we discovered that one of these compounds, which is very closely related to anandamide, the endogenous cannabinoid, it is really very close. Those of you who remember their chemistry can look at anandamide and can look to this compound that prevents vasoconstriction, and the only difference is a very minor one on the side. So here we have something that the body does, making a cannabinoid which has it affects some of the negative things that happen after brain damage. But another thing, bones. It is known that women in the Mediterranean region have less osteoporosis than women in the northern countries, in Norway, let's say. And the reason was, that's what was thought, that they use a lot of olive oil. So we looked at the constituents of olive oil and didn't find that they have any major effect on bones. But we thought maybe the major constituent of olive oil, which is called oleic acid, maybe this compound has a metabolite. And we looked together with the late Professor Bob for compounds that are in the body, and surprisingly they turned out to be close to anandamide. We didn't expect that. And here, if you see anandamide, this is the structure, we found that the body forms a compound closely related to anandamide, and it is a very potent anti-osteoporotic agent. So in the Middle East, women use a lot of olive oil. Oleic acid, part of it is converted into this compound, which is named oleilserine, a derivative of oleic acid, of olive oil, and that's one of the reasons why there is less osteoporosis. But the body makes this compound in all of us, and today I believe that the companies are working with oleilserine, this compound, as an anti-osteoporotic agent. So here we have different things. We had the brain trauma, we had bones, and I can show you what happens with the bones. The bones in an osteoporotic mouse go down, and you can see the green one is the normal one, and the red one is an osteoporotic mouse. If we give this compound, it not only stops the breakdown of the bone, but actually the bone starts recovering. Will that happen in humans? I hope so. And I want to end with something that we're working at the moment, and this is addiction. Addiction is a disease. The body sees addiction as a disease. And if the body sees addiction as a disease, chances are that it will try to find ways or to look for ways that affect the addiction. So we went ahead, and we, in this case, means a group of 4 researchers, 4 research groups. One is ours, and one in the US in Virginia, one in Canada, and one in Italy. We work together on this problem, which is a major problem today, addiction. And we found that, yes, our body makes a compound closely related to the anandamide and the other compounds that I mentioned that are related to cannabinoids. And this compound is, again, a fatty acid bound to an amino acid, closely related to anandamide, and it can eliminate the formation of addiction in mice. What was used, there is a method called conditioned place preference. Mice can go either to a place that has food with nicotine or food without nicotine. At the beginning they go 50% here and 50% there, but then they slowly learn, get addicted to the nicotine, and they go only to the food that has nicotine. This is called conditioned place preference, and this compound can break down the formation of addiction. And it can also do something else which may be even of greater importance. This compound can block the withdrawal symptoms of addiction, and in this case the withdrawal symptom both of nicotine and opioids. Now, one of the reasons why people go back and continue to use both nicotine, cigarettes, and opiates, heroin, is because of the withdrawal symptoms. They're afraid of the withdrawal symptoms. If they don't get their drug, they get into a situation where which they cannot withstand, and therefore they spend all their time looking for the drug. And this is one of the reasons why so many people get addicted and cannot get out of the addiction. Well, we found that oleoyl glycine not only blocks nicotine addiction, it does not block opiate addiction, it blocks nicotine addiction, but it blocks both nicotine and opiate withdrawal. Will that be useful in humans? We don't know yet. We've done that in mice alone, but I hope that maybe soon, within the next few years, we shall know that here we have an anti-withdrawal agent of major interest. Well, I would like to summarize what I've been telling you. The endogenous cannabinoids are involved in a large number of physiological processes, and THC mimics the effects of these endogenous compounds. CBD derivatives are of major importance, and derivatives of CBD or derivatives of CBD may become major drugs. And I spoke about the endocannabinoids, and I spoke about CB2 specific agonists, and I hope that there will be continued research in all these aspects. And I want to thank my collaborators in Jerusalem, both in my own lab, which is these, and with many colleagues, and also the collaborations we do with a huge number of colleagues all over the world. Thank you.